Well, well, well. What do we have here? Some eager young minds ready to learn about square roots. Hey, look, square roots cause so much trouble because of, well, students often try to learn how to handle square roots without actually learning what square roots are. And I think if you understand what they are, how to read them, what they mean, it becomes so much easier. So that's what we're going to do. We're going to break this down into 4 different lessons. We're going to take your time. You know, math is like dating. You don't want to rush in and do something stupid. You get your feelings hurt. All your friends are like, "Told you so, bro. Told you it was no good. I told you you're being dumb. Don't do it that way." Anyway, so let's go ahead and get into it, shall we? So here's what we've got. We got square roots like this. So the first thing I want you to know is that square roots are not an operation. They're just a number. They don't have an answer. You're sure you can simplify them sometimes. You can rewrite them in a new way that'll have the same exact value, but yeah, they're just a number. So where square roots come from is from squares, right? Square roots come from squares. So, like for example, if you had a square, and it's supposed to be a square. Let's say the side was 5. Would you guys agree that if you took that side and you squared it, that's how you would find the side? You get an area of 25, right? Right. So anyway, if you had a square with the side length that was x again is just an unknown value, the area would be x squared, right? So what square roots are really saying is like, hey, suppose I have an area that would be 16, an area of a square that's 16. How long would a side be? That's what it's asking. So if the area is 16, how long is the side? So wouldn't that be a side length of, if you had an area that was 16, the side length would be 4. That's supposed to be an S. It's a creative S, right? So that's fundamentally what square roots are talking about, right? They're talking about if I have an area of a square, how long is the side? So that's one good way to think about them. So this one's saying, hey, if I had a square whose area was 4, how long would the side be? And of course, the answer would be 2. Um, yeah. So here's the way I want you to read square roots. Square roots are asking a question in math. Square roots ask a question. They say, what number squared is the radicand? That's what square roots are asking. That's it right there. That's the big idea. If you keep that in your mind, then and a few other little things that are going to come up about rational and irrational numbers, and if each little part is simple as putting it all together, it can be kind of tricky. So that's why you got to be paying attention. And look again. Oh, keep saying it. I feel like I'm beating a dead horse. Look, learning is not a passive activity. It takes a lot of active engagement to learn. And the problem with a video is watching videos is entirely passive. You just sit back, hope to absorb it. It doesn't work that way, bruh. So you need to be pausing the video, taking notes. If I'm speaking too quickly or if I say something I don't write that seems important to you, you need to pause the video, write it down. Especially if you get confused. If you have a question, pause the frickin' video. Write down your question. Leave space so you can come back to it when you have the answer. When you answer that question, when you get that question answered, you need to pause the video, go back to where that question was, and write down your answer. That way you remember, and also that is some great notes that will help you, you know, take tests well and do stuff like that, right? So anyway, let's get back to it here, shall we? So what squared is the radicand? Now, the thing about the radicand is the thing inside the square root. So 4 here is the radicand. That's like the area. 4 is the radicand. It's the number inside the square root. So they're saying, hey, what squared is the radicand? Now, square root numbers have a special property. If you take a square root number and you square it, you multiply it by itself, what you end up with, the product, is the radicand itself. So for example, if I took the square root of 9 and I multiplied it by the square root of 9, it's equal to just 9. True story. 3 times 3 is also 9. That's why the square root of 9 equals 3. That's actually why right there. It's called the transitive property. You know, if A equals B and B equals C, then doesn't A equal C also? Of course it does. Yeah. So that's kind of what's going on there with square roots, okay? Now, not all square roots can be simplified. All square roots are just numbers. Some you can rewrite in a different way, just like some fractions you can rewrite in a different way. Like, so for example, if you had, 2 over 4, that's the same as 1/2. This is not the answer for that, because this isn't a question. That's just a number. Just like this is just a number. It's not a question. It's just a number. Now, the way we write that, it does beg a question. What number squared is a radicand? That's how you simplify it. But, not all of them can be simplified. For example, the square root of 7, that cannot be simplified because there's no number, there's no whole number, there's no integer times itself that equals 7. In fact, this is irrational, which means you can't write it as a ratio of integers. So other examples of irrational numbers, one you probably are familiar with is pi, which is the circumference of a circle divided by the diameter. There's another number you don't know about, it's called e, it's irrational. And if you have the square root of a number that has prime factors, it's going to be irrational. Now, if it is the square root of a square number, that's not a hashtag, that's a number. This would be hashtag, right? Math AF, always factor. If you have the square root of a square number, like 25, then that's rational, because you can simplify it and you can write it as an integer. Okay? Now, a couple things that you're going to have to be aware of. You need to know what a square number is in order to be handling square roots. So I'm pretty sure you guys are okay with this, that's equal to 9. People always say it's 3, though, because they're like, oh, that's a square. But that's just the number 9. That's the square root of 81. That's just 9. You can't rewrite 9. That's not 3. Anyway, these two are equal. But you have to know what square numbers are. So square numbers are, if you take a number and you multiply it by itself, the product is a square number. So the square numbers would be 1, 4, 9, 16, 25, 36, 49, 64, 81, 81, however you want to say it, bruh. 100, 121, 169, 196, 205. Oh, 225. However you want to say it. So this is 1 squared, 2 squared, 3 squared, all the way down to 15 squared, right? So you need to be familiar with these because you're going to see all kinds of those. Yeah, and so you got to be aware of those. So for example, like let's say you had the square root of 50. There's not a number times itself that equals 50. This is actually going to turn out to be irrational, but you can simplify it. And we're going to get into this a little bit more in the next lesson. But for now, check this out. Here's what you're going to do. You're going to take that radicand and you're going to factor it to find the largest perfect square. It's true that 50 is 1 times 50, but 50 is not a square number. It's 2 times 25. That is good. And there's also 5 times 10. Those are all the factors of 50. This is the largest square number. It's true 1 is squared, but it's not the largest. So the way you would write this is you'd separate it like that. Remember, if you're one of the things we're going to learn is if you're multiplying square root numbers times square root numbers, you can actually multiply the radicands together. So these two things are equal. This says what squared is 50? Well, this says what squared is 25. This says what squared is 2. I don't know what squared is 2. That's irrational. I do know what squared is 25. That's 5. So what we're saying is these two are the same. In fact, we're saying that if you had a square and this one side was 5 times the square root of 2, the area would be 50. That's what we're saying right there. That's it. So now, look, you might not be very comfortable with this right now. That's okay. We're going to get into that in greater detail very soon. But you should be able to do this. You also need to know what square roots ask. You also need to know what square numbers are, what irrational numbers are, and what rational numbers are. So, anyway, that's all the stuff right there. Man, you might need to rewind this. There's a ton of information on this one little page right here. But anyway, hope it's been helpful. Hope it's been useful. Be a good student. Be actively engaged in the video. Take notes, write questions, all that kind of stuff. Hey, you guys are looking good today. Hold on. You're looking good today. I don't know if anybody told you that, but it's true. Hey, I hope you have a good day. I'll talk to you soon.